So I can see the part in the top view. So I'm just going to do a fit view so we can see it in the isometric view as well. Okay, so one of the things that you wanted to do was take this part and then you wanted to basically flatten it out. You want to put it on a plane, right?
Correct.
Okay. So the way you would go about doing this is you would go into the mill browser, and on the machining browser, you would go down to Utilities, and then you'll find a tool in here called Explode Cabinet Design. So I'm going to select Explode Cabinet Design, and this will display a dialog which allows you to choose what you would like to explode. I'm going to say all the objects that are visible. I can place them all on a single row along X, or I can do a column along Y, or I can do a fixed distance along X, and then it'll basically create multiple rows.
Wow.
Or I can do multiple columns. So for the purpose of our discussion here, I'm going to say single row along X, place them all along X. And I can specify the spacing between each component as it's being placed. So the distance between each component. So for example, I could say, give it a 1/2 inch apart. Okay?
Okay.
And then you have the choice to create both the solids and 2D curve outlines, or you can just choose to do 2D curve outlines or 3D solids only. And
so with 3D geometry, what is it doing? Is it creating all the different sizes, all the different sides of the geometry?
So when you say create both 3D geometry and 2D curves, it's going to basically take this as this is like a poly surface that you have.
Right.
So it's going to basically just flatten the poly surface and put it on the XY plane, so you don't have to do the rotation manually.
Okay. All right.
Okay. So I'm going to select 3D and 2D curves. We'll create the geometries in a new layer, and then we'll place all the curves in one plane, and then we'll hide the originals, and then select OK here. So now when you perform the step, it'll automatically go ahead and place them in along a row, since we chose to place it along a row here, right?
Okay.
So you have each of these panels now. It'll look at the model, look at the orientation, and figure out what is the best way, which would be the top or bottom, based on the number of features you have. If you had like holes or pockets, like blind holes or pockets, so that would typically go on the top. So for CNC routing or machining, that would be the best way to go about it.
Huh. Interesting.
Okay. So now the parts are all flattened out in here. So if I select them all, you see there's a total of 28 extrusions and 16 poly surface and 136 curves. If I select the curves, you'll see it also maintains the outline around each of these parts in here.
Oh.
Those are curves. It creates those outlines for you around each of those pieces. Now, we can delete those outlines out. We can say, we don't need the outlines. So when we did the Explode Cabinet Design, that's what we call them as curves. So it'll create both the curves and it'll create the, solids when it flattens it out. So since you're primarily interested in just the solids, I can choose not to have the curves.
Well, actually, it's the opposite. I'm interested in the curves because the softwares won't read the solids. They'll just read the 2D lines.
Oh, okay. All right. Then we can just do the curves. And one of the ways I would go about doing it is then just do an undo here. And then I can go back and see there's your part. I can choose Explode Cabinet Design. And then I can say create 2D curves only. And then hide the original, place them on a new layer. So it'll basically just create the curve geometries for us.
Yeah. Yeah. Wow.
All right. So it automatically creates those curves. And now we can take these curves and we can nest them into a sheet.
Will it scale it down for me? Because I need it on a 24 by 36, and obviously this scale is 1:1.
Okay, so you want to scale all of these parts to a smaller size?
Yeah, because it needs to fit in the laser cutter first.
Okay, so what you would do is use the scaling in Rhino. You can basically scale it by the distance amount ratio you want it to. You can do a select all, and you can do a transform, and then you scale.
Okay. So then that's what I expected. Okay, so it's not part of the work. It's not part of the software's workflow. I'm using Rhino at that point. Okay.
Right, you're using Rhino, and then you can say the origin is 0, and then you can specify the percentage you want to scale it. You can say half the size. You can say 0.5. You can scale it down to half the size.
Okay. So now I can also, now you're going to show me the nesting, right?
Yes, I will show you the nesting process in here. So would you like me to have it scaled, or would you want me to do it to the original scale?
Well, let's do, I think what I would probably end up doing is nest first, then scale.
Okay. All right. Now, so this is one of the ways how you can, create this explode cabinet design and explode these into smaller segments, right? And then you want to go ahead and nest them. So we go from RhinoCam's mill to the nest module. And you can define your type of nesting you want to perform. So we'll do a true shape. And then you go to select the sheets. You can either define your sheet size in here.
Yeah.
Or you could even draw a rectangle that represents the sheet size. If you want to draw something in Rhino, have it pre-drawn, I can basically create a rectangle in here. I could say my starting corner is going to be 0, so I can maybe have a new layer for my sheet. It's already built into Rhino, and you can have your sheet size pre-created in here. So it could be 24 by 4 by 8, or whatever size that you want to create your sheet. Would you have
24 by 36 is what the sheet size will be, but right now we would need to scale. We would actually need to scale first. So if we scaled it down, I think if you scaled it down to 1/8 of its original size, then it should fit on that 24 by 36.
Okay, so we'll have to scale it down first then. So
yeah,
we'll do 24 on the X and 36 on the Y, or is it the other way around?
No, it doesn't matter.
Okay, 24 by 36. Okay, so now I have defined the sheet. I can take this part and scale it. Do a scale, and then you want to do 1/8.
Right.
0.125, and that's scaled. Okay. To 1/8 of its size. So I've just staged the parts to be nested outside of the sheet. So I can click on select curves, highlight this as my sheet, and then I go to parts to nest, choose the parts, click on select parts, window select all of these, right click, and I'm going to select use for engraving and sign making. So it groups all the inside items within the part as one entity. Okay?
Yeah.
And now I go down to, I can specify the quantity of each part I need right here. And then I can specify the priority, the orientation, grain direction can be set right in here. And then you go to choose the nesting parameters, and you can set the distance between each part, the minimum distance you want to maintain between each part.
Right.
And here I can say maybe 50 thousandths or 1/8 of an inch. The distance from the edge of the sheet to the part, I could say 25 thousandths. And then I can have it compute or determine the number of sheets required to fit all these parts. It says 1 sheet is all you need. And now I'm going to select execute nest, and you'll see that the parts are nested.
That's pretty cool.
Yeah, so you have all of them nested. So if you want to go back and change any of these parameters, I could go back in here and say the distance between part to part, I'll do 1/8 of an inch. From the edge of the sheet to the part, I'll do 50 thousandths. Go back and do an execute nest again. And you can preview the nest, and you can then go down to commit nest, and then you can say commit nest. That'll basically create the part in the sheet, place it on a new layer.
Very cool.
Yeah. So now that you have these created, you will be able to.
Will it label? Can it label the parts for me?
What you can do is you can use what's called our tagging option in here. So we can go back to choose nesting parameters. We can choose how you wanted to create tags. You can do annotation, or you can use a geometry. So if you wanted to create as a geometry, you can specify a height for it. Let's say I want to put in 1. You can say execute the nest, and you'll see it basically numbers them out for you. It places a number in a sequence automatically. And I can go back in here and specify the height, or I can even do it like an annotation dot, and I can specify it. And you can see it'll create an annotation dot. I can make it smaller as well.
Yeah, that's exactly what I would need. So then
The annotation dot cannot be machined because those are not as curves, but if you choose them to be created as a geometry,
yeah.
I can give it a height in here or size for the geometry. And now I can go ahead and when I commit the nest, you'll see these are created as curves, and you will be able to machine them. Now, since these texts are a little too large, I'll probably have to go back and make them smaller because of the size of these drawings in here.
Right, right. Wow.
The parts are pretty small, so you'll have to, now when you do a commit nest, so it'll create those numbers as well for you. Any other questions, sir?
No, this is nuts. Wow. How long has the software been on the market?
Our Nest module, our RhinoCam product has been there since I believe 2004, RhinoCam.
Okay.
And our nesting module has been there for more than, I would say, for the past 6 or 7 years.
6 or 7. Wow. This is awesome.
We keep adding features and make improvements to the nesting product.
Man, in 20 minutes, you just knocked out all of this stuff, and really less than that because we did some back and forth. But realistically, this workflow is pretty amazing. I mean, all I have to do is really just focus on making the objects, and then this thing does all of that other post-production type stuff.
Right. So it'll allow you to flatten them out using explode cabinet design, and then you can nest them into a sheet. Now you can also explode solid panels and nest the solid models into a sheet as well. So if all the parts have the same height or thickness, then you can explode all of them into one sheet. If they have different thicknesses, then you will have to probably do it in different sheets.
Yeah. Okay.
So once you have this done here, the next step is to go into your machining process. So we have these parts now defined in here, right? So we'll now go from the nesting module back to the milling module here. And you can create your tool paths for your CNC routing process. So you can define the machining process. It's a 2 and 3 axis machining. For post, you can select the CNC equipment that you want to write the G-code output for. So that's the reason at the start of this demonstration I had asked you, what is the CNC machine tool that you're working with? So you can select the post processor that would be the most appropriate for it in here. I can even pick like a generic one, which will do a standard G-code output in here. So we have several different posts. I'll just pick general. You can choose the extension as NC.
Well, let me state that the one that I'm interested in getting for myself, because right now we're just kind of testing workflows for with this maker company, this maker studio, but we're going to incorporate this equipment in our own office. And the one that I'm looking at is ZenBot. So I don't know what interface. I don't know if you've heard of it and you know what interface it is, but let me pull up their website, ZenBot CNC.
Yes, I've heard about their machine. I believe they use Mach 3 as the control software.
Yeah. Let's see. I'm on their website now. Okay, so yeah, they use Mach 3.
Okay, so we have a post processor included for Mach 3. You can output in inches per millimeters. And once you have the post set up, you can define your stock material. You can choose stock, box stock. You can give it a height, whether it's going to be 1/2 inch, 3/4, or whatever the thickness of the material is going to be. And
will it simulate the cut?
Absolutely, absolutely. We will then go ahead and align the stock to the part. The next step is basically creating a toolpath. So we'll choose a profile cut, and we'll choose select curve regions, and you can either select each curve geometry individually, or you can select them all together. So I can individually pick them, or I can drag a window to select all of these geometries in here in one operation. So there's different ways how you can select the objects, right? So basically here I'm showing you how we are taking advantage of Rhino selection to select the parts. So you're completely staying inside Rhino to create your machining operations. And I'll just pick these for now here, okay? And then I'll skip some of these so we can program a toolpath. Now the next step is to pick a tool for it. How small of a tool you want to use, an 1/8 inch, a 1/16 inch.
Can I add more tools to that list?
Absolutely. You can create tools of different types. And you
Wow.
can tools. This is just a library of tools I had previously loaded, so it loads the library automatically. You can create your tools, set your feet and speeds. You can define all of that stuff.
Okay.
And then you can go ahead and specify your clearance for your safety transfer motions. You have your cutting parameters. You can choose you want to cut on the outside of each of these curves for the profile operation. And then you can go to your cut levels where you can specify the total depth. I put in 1/2 inch as a sheet height or thickness. I can cut it in one pass, or I can break it up into multiple levels. Specify entry and exit for your lead in and lead out, or you can just do a plunge. Specify any additional parameters. And then you can go ahead and also create a sequence by sorting them out, and you can generate your toolpath. So in this process, it's going to create a profile operation in here.
Yeah, I'm familiar with MadCam. I did all of this with MadCam a long time ago, but this is great because then I don't need to. I can stay all entirely within Rhino, which is big advantage.
Stay within Rhino Cam to do your cabinet explode, create your nesting, and then program your toolpaths.
Yeah. Wow.
Okay, so you can see the toolpath, the simulation. So once you have all of these toolpaths programmed, we could then go ahead and take a look at the estimated time for cutting it based on the parameters, feet, and speeds that we put in here.
Right.
And then post them out to the machine tool. So we can do a right click, go to information. We'll tell you the estimated time. And then finally, you want to do a post. And then you can choose where you want to save the code. And there's your output file. It's generated for a Mach 3 controller. And you can transfer this out to your machine tool.
Outstanding. With this, do you have 5 and 6 axis capabilities?
We do all the way up to 5-axis machining in RhinoCam, uh, starting from 2 to 5-axis machining. A 6-axis, we work with robotic arms through one of our partner products called IRB Cam in addition to RhinoCam that can
Right.
be used for programming 6 and 7-axis robotic arms.
Okay, okay. That might be a capability farther down the road, but for now, I'm just going to be dealing with 3-axis.
Okay, so for 2 and 3-axis, what I would recommend is the RhinoCam standard configuration, which will also include nesting, includes the explode cabinet design. Post processor for Mach 3 comes included with it as well.
Okay. All right. And this is subscription based, or this is one-time fee? How does this?
RhinoCam is a perpetual license. It's a permanent license.
Okay.
And we do offer what's called a annual maintenance subscription program, which gives you access to priority support, gives you access to monthly webinars, access to CamJam video guide, and a lot of additional resources. And it'll include the version upgrade, so you don't have to purchase an upgrade. The maintenance will cover that as well.
Okay. How much is that annually?
I can certainly get that information to you here. So all of this information about our product pricing, the maintenance, everything is listed on our website, and you can.
Okay, okay. I'll talk to Kelly about it. That's fine.
Okay. Would you have any other technical questions on the demo here, sir?
No, this answered all of my questions. I actually didn't know it did the this last component, which is the simulation. I didn't know it did all of that. So that's a pleasant surprise.
Okay. Glad to know that you like what you're seeing here.
Yeah, this is very, very impressive. And the real kicker is the annotation, the geometric annotation, because that's always that, or at least when I was originally using this workflow, that was the nesting was a pain in the neck, and then the labeling was a pain in the neck. So for all of that to be automated is, I mean, that's pretty amazing.
Yeah, so it'll automatically place numbers we call it annotation, and it'll place them based on it'll have a number for each part. Now, if you want to have custom numbering and custom placed in certain areas location, you can actually use Rhino to number these parts, and then when you nest them, you select the numbers as well in addition to the part you're trying to nest. So that'll basically nest it with the numbers that you have defined.
Oh.
You don't have to enable annotation in RhinoCam's nest module.
Okay, so you can just use Rhino's normal text tool.
Yes, you can use a text tool in here. Use the text object. Use curves, and then you can place numbers for each of those parts. And then when you nest them, you select them along with it for your parts to be nested, and it'll basically maintain those numbers that you created, so you don't have to enable the annotation.
Right. Got it.
So if you need specific part numbers for each part rather than auto numbering them.
Okay.
Okay.
All right. That's great.
All right. Any other questions here on the demo?
No. Very helpful. Your name's pronounced Uday?
That is correct. U-D-A-Y.
Thanks, Uday. I appreciate your time.